All right, good morning. So we are going to look at dividing polynomials. I'm going to make these a little bit bigger so that we can see them. Sorry, it was late last night when I found these problems. So if we're looking at dividing polynomials, these are dividing a polynomial by just one term. So this is a little bit different, or it should look kind of familiar. If we have a polynomial and we're going to divide by one term, then basically it's kind of like the distributive property. We have to divide every single one. So you have to take the 15r to the 10th, and it has to be divided by 5r to the 4th. And then you have minus 5r to the 8th, and it has to be divided by 5r to the 4th. And then you have plus 40r to the 2nd, and it has to also be divided by r to the 4th. And so once we do that, then we're just going back to monomial rules. And so 15 divided by 5 is going to give me 3. I'm going to subtract my exponent, so that's going to give me r to the 6th. Minus the 5's are going to cancel out. 5 divided by 5 is 1, and I don't need to write that coefficient. R to the 8th divided by r to the 4th. If I have 8 on top and 4 on the bottom, that leaves me 4 onto the top, or r to the 4th. 40 divided by 5 is 8. If I have r to the 2nd divided by r to the 4th, that means we're going to have 4 on the bottom and 2 on the top. So 2 are going to cancel out, but it's heavier on the bottom. So you could either write it as 8 divided by r to the 2nd. And there are some of you who might even use negative 8 to r to the negative 2, but this is what I'm doing. Remember our monomial rules. If you watch the monomial rule video, then you would know that we subtract the exponents. We subtract exponents. That was a few weeks ago when we were working with exponentials. I'm actually going to pause the video for a second, but then work these other, well, I'll work one more with you guys. If you have 30, this is just written differently. It just means we're dividing, but it doesn't mean you just divide this term. You have to divide all of them by negative 6x squared y, negative 6x squared y, negative 6. Every single term needs to be divided by negative 6x squared y. So I'm going to write this answer in red so it stands out. Negative 30 divided by negative 6 is 5. 3 x's on the top and 2 on the bottom leaves me 1x, and both of the y's, y divided by y, cancels out. 12 divided by negative 6 leaves me negative 2. My x's cancel out, and y squared divided by y leaves me with a y. Negative divided by negative gives me a positive 3. X's cancel, y's cancel, so it just stays positive 3. This situation, where we have 4a to the negative 1, if you have something to a negative, that just means you bring it down to the denominator. So once we bring that down to the denominator, then that just means we're going to divide all of them by 4a. Every term needs to be divided by 4a. So the 4's cancel out, and we're left with a squared minus 2a plus a over 4. Dividing by one term, or dividing by a monomial, is completely different than dividing by a polynomial, which is what we are going to look at today. Is there anybody who needs more time? This is an example of where we are no longer dividing by a monomial, we are actually dividing by a binomial. Bi means 2, just like a bicycle has 2 wheels. We have 2 terms here on the bottom. Now, we can't divide each term by f plus 2. That's not going to work. So we're actually going to look at 2 different methods today. The first method that we are going to look at is called long division. How many of you remember long division from many, many moons ago, right? Where you take the number and you ask how many times it would go in. Real quick, an example of long division is if you have 35 into, I don't know, 75 for 8, 7,548. 35 doesn't go into the 7, right? We can't multiply 35 to go into 7. Can we, is there something that 35 goes into 75 at least once? And possibly, I'm going with, Kobe says twice, because what's 35 times 2? 70. So if we have 2 times 35, that gives us 70. And then what do? Then we subtract. We actually change the sign. We said we've already used 70, and then we are going to be left with 5. 35 isn't going to go into 5, but if we bring down the 4, can 35 go into 54? Yes, 35 can go into 54. How many times? Just once. So we put that 1 up there. We say 1 times 35 is 35. And then what do? We subtract. We change the sign. And that leaves us with, we have to borrow. It's 4, 14. Anybody get 19? Okay. And then 35 does not go into 19, but what happens if we bring down this 8? So now we have 198. So I'm guesstimating, I think we might even be able to do 5. You think we can do 5? All right, so let's try 5. 5 times 5 is 25, carry a 2. And 5 times 3 is 15, plus that 2 is 17. And then when we subtract, we get 3 and 2. So then what do we do with the 23? It's 23. Now, if you wanted to keep going after the decimal, could you put a decimal and then do what? 0, and we could keep going and going and going. What's another thing you could do? At 215, we have 23 out of what? We have 23 35ths. If you stopped right there, you have a remainder. Anybody remember that whole, the R? Who had a math teacher who let you put R23? Oh. Yeah, I know. They're out there. It's actually, that means we have 23 left when we are dividing by 35. So that's why it's 23 35ths. Does that work? Everybody okay with that? Now, watch what happens when we want to use long division with polynomials. We are going to say, I want to divide by f plus 2, and I'm dividing into f squared plus 7f plus 10. Please write these notes down. I'm not doing them for me. I understand how to divide polynomials. These are for you. So you ask yourself, does f go into f squared? Okay. What if you say f squared divided by f, what would you be left with? An f. Or if the other thing is, what can I multiply f by to get an f squared? What can I multiply this by? It would be 1f. Because f times f gives me f squared, and f, and then I have to multiply the second term, right? Just like we did with the numbers. What is f times plus 2? Plus 2f. Good. And then when I got to this point, I then did what? I subtracted. But you have to it would be like subtraction. Both of these have to be subtracted. So this becomes a negative f squared and a negative 2f. You change your sign. So what happens to my f squareds? They cancel. And what is 7f minus 2f? 5f. 7 apples minus 2 apples is 5 apples. We can finish if we bring down the plus 10. Does f go into 5f? Or what do I have to multiply f by to get 5f? Plus 5. And then I'm going to say 5 times f gives me 5f plus 10. And then why is it 0? Because we have to change the sign. And in this case, it does leave you with a remainder of 0. So your answer is f plus 5. There are. We're gonna look at long division first. We're gonna look at long division first. I would not be a good teacher if I only taught you synthetic division. Now, if this was 10 divided by 5 equals 2, then how could you check your answer? It would have to be 2 times 5 equals 10, right? 2 times 5 equals 10. So does x plus 5 times x plus 2 equal f squared plus 7f plus 10? How could you figure that out? How could you multiply the f plus 5 times the f plus 2 to make sure you had the right answer? What happens if you have a binomial times a binomial? I heard it. Who said it? FOIL. What's f times f? F squared. What's f times 2? 2f. What's 5 times f? 5f. What's 5 times 2? 10. Does that give me my original f squared plus 7f plus 10? Yes. So it checks. All right, we need to do another example. Let's try this one. One of the things that you need to understand is that when we're dividing, polynomials don't necessarily have a placeholder. Because if we have a 0x squared, would we write that in there like you would in a number? No. So here we're going to say we're dividing by x plus 4, and we are dividing into 2x to the third. But if you notice, we go from x to the third to just x. So I'm going to add in 0x squared plus 6x plus 152. Because when we start multiplying, we're going to get x squareds. And if we don't have a placeholder for the x squareds, it's going to screw everything up. It's going to make it all crazy. Okay? All right, so let's look. What do I multiply x by to get 2x to the third? We need the 2. We have 1x, but we need an x to the third, so it's going to be x squared. Good. And so we say 2x squared times x gives me 2x to the third. 2x squared times 4 is going to give me what? 8x squared. And then what's the major thing that we can't forget? Change the sign. I added it in. I said we were going to put a placeholder in. So those cancel, and it leaves me with negative 8x squared. and then I bring down